Hi everyone, it's Coach Fred here. I'm on take 2 of this video. So today I'm going to be going over simplifying radicals that you learned in Algebra 1, sometimes called simplifying square roots, okay, because a radical, the symbol, we call it a square root symbol. Now, I want to make sure that we understand, like, if I tell you 5 squared, right, the square root of 25 is 5 because it's undoing the square. It's undoing that perfect square of 25. And so that's what a square root does. And so we do need to know our perfect squares to do this, okay? So to simplify a radical, you're going to have to know your perfect squares. So, I mean, going through that, the square root of 1 is 1. Actually, the square root of 0 is 0. I should probably know that, but the square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. The square root of 25 is 5, and so on, right? Square root of 36 is 6. You could go all the way up. I do really like to know the square root of 100. 100 is 10. I love square root of 225 is 15. You should be able to go all the way up to 17 and feel comfortable. So I want you to practice those this summer. But how do we simplify a radical? Well, it's easy if it's a perfect square. These are all perfect squares. So their results, it's going to give me a real number. But the problem is when I have numbers that are not perfect squares, such as the square root of 3. The square root of 3 is an irrational number. That means that if I put it in my calculator, I'm going to get a non-terminating, non-repeating decimal. So it's an irrational number. It can't multiply with a real number like 2. So we've got to find ways that maybe we can simplify and pull out these perfect squares if they're in them. The square root of 3 is in its lowest form. There's nothing I can do with it. The square root of 5 is another example. There's nothing I can do with it. But the square root of 8, if I look at the square root of 8, I can actually break it up using multiplication and using one of the perfect squares. And I actually want to think of breaking it up into the largest perfect square. That's a factor of it. So I see that the square root of 4 is the largest factor of 8. So I can rewrite it as the product of two different radicals. And then I can simplify square root of 4 into 2 times the square root of 2. Okay, so we've simplified it. Now square root of 2 is irrational and it's in its lowest form, so we leave it. Now normally I'm going to write it like this, 2 root 2. But I want to make sure you understand that's being simplified. All right, let's try another one, the square root of 24. Again, I'm looking for the largest perfect square that is a factor of it. Okay, so the square root of 4 goes into it, I think. So square root of 4 times the square root of 6. That would simplify to 2 rad 6. All right, what about if they're bigger? What if I gave you like the square root of 72? Well, here's a little thing I want you to really think about. A bunch of you are going to jump to the square root of 9. And square root of 9 is a factor of 72, but it is not the largest. So if 9 goes into the number and it's a large number, I also want you to check 36. It's just kind of like a trick because it happens a lot. Well, it just so happens that in this case, 36 does go into 72. It goes in twice. So I can rewrite it as a product of multiplication. So root 36 times root 2 is the same as 72. So that would simplify to 6 rad 2. We can say 6 rad 2, 6 root 2, 6 square roots of 2. All right, let's talk about other numbers like the square root of 48. Most kids clearly see 4 goes into that. And that's true, but 4 is not the biggest. So when these numbers are bigger, you want to try other numbers. So if 4 goes into it, I always tell students, check 16. All right, does 16 go into 48? Well, it does. It goes in 3 times. So I can simplify this to 4 rad 3. All right, now what if I did that and I took that root 48 and I put the number 2 in front of it? Well, if the number 2 is in front of it, it is being multiplied, even if that multiplication symbol is not there. So if I simplify this 48 into 4 root 3, I actually have to multiply the real parts, and the real parts are the 2 and the 4. That would give me 8 root 3. Okay? All right. Now, what happens if we square a radical? What if I said root 5 and I squared it? Well, let's remember that squared means root 5 times root 5. It means 2 of them, which would give me root 25, which is 5. Let's try another one. Root 7 squared. Well, that means root 7 times root 7, which is root 49, which is 7. So what you may be noticing is that square is actually undoing the radical, and that's because they are inverse operations of each other. The square and the square root are inverse, so they undo each other. So that square actually cancels out the root, leaving me with the number that's on it. So if I see root 8 squared, then I know my answer is just 8. All right, the last thing I want to talk about is adding radicals. Now remember I told you that radicals were irrational. So you can't add them together and say this is root 10. You have to follow a process. And the rule is that you treat them like they're like terms. So this would be x and this would be 2x. Well, what would you do with x and 2x? You'd say 3x. You wouldn't change the x and make it x squared. So if you're adding radicals, this would be 1 root 5 plus 2 root 5, which give me 3 root 5. All right, so if I have 5 root 7 plus 6 root 7, that would give me 11 root 7. All right, I can subtract as well. 8 root 3 minus 2 root 3 would give me 6 root 3. So addition and subtraction are different with radicals than multiplication. And division is just a whole nother animal. We'll talk about that another day. So have a great day, guys.